ahead and talk about the two types of chemical bonding, and that's ionic and covalent bonding. And first, we're going to answer the question of why do chemical bonds form? Atoms bond together when their valence electrons interact. So atoms are more stable if they have an outermost energy level that's full. So they want to have an outermost energy level that's full. Now remember, energy level 2, 3, and 4 are full when they've got 8 valence electrons. Your first energy level is full when it has 2 electrons, valence electrons. Now, atoms are going to form bonds so that each atom has a stable electron configuration, and all that means is that that outermost level is full. So if their outermost energy level on the atom is full, then that means that they have a stable electron configuration. And as I said at the beginning, there are two types of chemical bonding. The first one is ionic bonding. The second one is covalent bonding, and we're going to discuss ionic bonds first. Now, ionic bonds form from the attractions of the positive and negative ions. And so when you have something that's oppositely charged, they're going to be attracted to one another. Opposites attract. Let's talk about metals and nonmetals. Remember from our last video, metals form positive ions because they have 1, 2, or 3 valence electrons. That means that they're going to give those electrons away because there's so few of them, meaning they're giving negative away, so they become positive. Nonmetals, if you'll remember, they're going to have 5, 6, 7 valence electrons, and that means that they have so many valence electrons, they just want to take more in to make their outer level full. So nonmetals are going to form negative ions because they're taking more negativity in. Now, ionic bonds are formed by the transfer of electrons. That is important. You must know that ionic bonds have a transfer of electrons. And you also need to put in here that metals and nonmetals make up the ionic bond. That's what your second little bullet point was when it says metals form positive ions and nonmetals form negative ions. Put somewhere on your notes that an ionic bond is consisted of a metal and a nonmetal. That's an ionic bond, so make sure you know that because you're going to have to be able to distinguish between an ionic bond and a covalent bond. So an example of an ionic bond is salt, and it's made of a large network of oppositely charged ions. It's a bonded ion network, and we've talked about salt before. Sodium is a metal, chlorine is a nonmetal. When they come together, they're sodium chloride. Now, this is an example of ionic bonding, and this is the sodium and chlorine example. If you'll notice here, sodium has 1 valence electron, and chlorine has 7 valence electrons. So if this sodium gives its electron to chlorine, it gives chlorine 8 on its outermost energy level, and then it gives sodium 8 on its outermost energy level. So this makes both of them happy. It transfers the electron and then creates a chemical bond. Now, what holds those two bonded ions together when they're ionically bonded? It's the opposite charge from the positive charge ion and the negative charge ion that actually holds those two together, and that's what forms the chemical bond. Now, ionic compounds are in the form of networks, not molecules. It's the bonded ion network, if you'll remember from our last video, not a molecular structure. We're going to talk about covalent bonds. A lot of times are in the molecular structure. If you have something that is ionically bonded, like salt, when you melt it or dissolve it in water, it can then conduct electricity. So if something is an ionic bond, you can melt it, dissolve it in water, and then you can use it to conduct electricity. The solid salt or the solid ionic compounds, they don't conduct electricity, okay? And it's because their atoms and the ions are so closely packed together that they're locked into place. Once you dissolve them, those ions break apart and dissociate, which means they dissociate from one another. They're not associated with one another anymore. And once those ions come apart, it allows freedom for the electricity to flow and be conducted. So if you dissolve an ionic compound in water or melt it, you can conduct electricity because the ions being dissociated and then allow them freedom to move. Now, let's talk about oxidation numbers. Oxidation numbers are the numbers of electrons an atom can gain or lose when they are bonding. So if you'll think back to our sodium and chlorine example, sodium can lose 1 electron, so it's going to give it an oxidation number of +1. That chlorine can gain an electron, so it's going to give it an oxidation of -1. And so these oxidation numbers also tell you the charge of the ion. Now, I know that seems like it's backwards, because if I'm gaining an electron, I'm gaining more negativity, so my oxidation number and charge has to be negative. If I'm losing an electron, I'm losing negativity, so it makes me become more positive, and that means that I have a positive oxidation number or a positive charge. And remember, the oxidation number equals the charge. They're the same thing. And when you have an oxidation number or a charge, you have to have the sign and the number. It has to have a plus or a minus, and it has to have the number following it. Now let's label these in our periodic table. So make sure you go ahead and get your periodic table out. And here's an example. The hydrogen family, or the alkali metals family, has a +1 charge because all of those have one valence electron and they want to give it away. So they have a +1 charge. The second column, which is alkaline earth metals, is a +2 charge or oxidation number because they have 2 valence electrons and they want to give those 2 away. And so on and so forth. Now let's look at carbon, and it's the column that it's in. It has +4 or -4 because it could, since it has 4 valence electrons, that's right in the middle, so it can either give them away or it can find 4 to come and make it happy. So it can be either or. Now let's look at the nitrogen family, the column right underneath nitrogen. You have -3 there. It's because they have 5 valence electrons, so they need 3 more electrons. So that means they want to gain 3 electrons, which gives them a -3 oxidation number or charge. Now, you need to label these because this is going to be important. You're fixing to learn how to make ionic bonds, and you're going to need these numbers to help you do that. So one more example before we move on, and let's look at the column and family that oxygen is in, this column. It has a -2 oxidation number or charge. You can call it either one. Just know that it is both. And oxygen has 6 valence electrons. You should know that by looking at your periodic table. And since it has 6 valence electrons, it needs 2 electrons to be complete and to be happy. And so that's why it has a 2 negative charge, meaning it needs 2 electrons. The positive numbers mean they need to give them away. The negative numbers means that's how many they need to get. Now, over here is where the transition metals usually are, and it doesn't list all of them. And we do not put charges with the transition metals because transition metals are just like their name. They transition. They change all the time. Transition means to change. And they change charges. So like copper could be copper 1 or copper 2 plus, 1 plus or 2 plus, and we don't know which one it is every time. So we can't put a oxidation number above each column because sometimes those change in the transition metals. However, the ones we have labeled will never change. Everything in those columns that we have labeled will always have that charge. Now, there are 2 ways to make ionic bonds for writing formulas. So you need to choose whichever one best fits you, okay? And if you look, they're on the bottom of your page. And we're going to talk about this, and we're also going to go over this and do some examples. First of all, before we learn the first method of making ionic bonds, let's make sure we understand this. If you'll see at the top, Li2 with the 2 lower than the I, that is a subscript. We've talked about this before. Submarines go below the water surface. Subscripts kind of go below the line or below the other letters. Now, Li1 plus is, the 1 plus is a superscript because it flies high above the element. And just like Superman flies in the air, superscript is the number at the top. Now, a superscript is always going to be the charge, so you have to have the number and the sign. You can't just have 1, 2, or 3. You have to have 1 plus, 2 plus, or 1 minus, 2 minus. The subscript always represents the number of atoms. So when it says Li2 at the top, that means I have 2 lithium atoms. So when the number's at the bottom, it tells us how many atoms. When the number's at the top, it tells us the charge. All right, let's go ahead and look at these methods that we have. The very first one is going to be the crisscross method. Okay. To me, this is the one I like the most, but you may like the other better. So let's look at the example that we have on your notes. We have lithium, and if you're going to do crisscross or the other method, you have to know the charges. So when you do lithium, you basically go to your periodic table where you just label the charges. Look where lithium is, go to the top and see what charge it is, and you should see that it has a 1 plus charge, okay? Then you need to find oxygen, because we're working with oxygen. find what its charge is, and you should see that it's 2 negative. Now, the crisscross method simply means this. You take the 2 negative, that's with this oxygen, and you're going to put it as a subscript for lithium. And you take this 1, so you take this 1 plus, and you're going to use it as the subscript for oxygen. So when you write the compound or the ionic bond, you're then going to say Li2, because you put the 2 down to the subscript for lithium, and then O1. But actually, you always drop 1s. You never leave 1s there. So we're going to, for it to be official, need to just say Li2O. And then this is the answer for that. Now, let's look at this exact same example, but using the other method. The other method is counting charges. So if you like crisscross, look at this one also and just see if you like it. If you don't like it, then just disregard it, and you can use either one, like I said, that you need to. Now, one thing real quick, when we're making ionic bonds, the charge of the compound is always going to be 0. So make sure, like over here, if I have 2 lithiums and they both have a 1 plus charge, that means I have a 2 plus charge. If I have oxygen with a 2 negative charge and there's only 1 of them, then that means those cancel out. The charges have to cancel out. If they don't, then you've done it incorrectly. So there is another way to do that. You can say lithium, 1 plus, and then you look and you've got oxygen, which is 2 negative. Those do not cancel out. The charges don't. So I look and I say, what do I need to make sure that these cancel out? And so I know that I've got to go over here and add another lithium. Now the charges cancel out because we have plus 1, that equals plus 2, and then we have negative 2, they cancel out. And then you just count what you have up here. I have 2 lithiums, so I put Li2. I have 1 oxygen, so I just put 1 oxygen, and that tells me the answer. You can use either one of these methods that you would like. It does not matter to me. You choose what best fits you. All right, and just a reminder, these are the formulas for this compound, okay? So when you make these ionic compounds, you're writing their formula. And so this is the formula, that's what they're called. Up here, when you've got an Li1 plus, remember that's just an element. So this is now the compound, and this is the formula for the compound. Once we learn how to name, you're going to learn that this is lithium oxide. Because with ionic compounds, you keep the very first one that has the positive charge, this is the cation. It uses the same name that you find on the periodic table, just lithium. It never changes. And then you take the root word of the anion, or the negative ion, you take the root word, and it's originally oxygen, so you use ox, and then you're going to add an IDE on the end. But we're going to watch a video about naming. I just thought I'd throw it in there. So this is the name of the compound, and Li2O is the formula for the compound. So make sure you know the difference between those, because if I ask you to give me the formula and you give me lithium oxide, obviously that's going to be incorrect. So make sure you remember what the formula is, what they look like, and then obviously naming them is going to be where you write it all out. Now let's go ahead and talk about covalent bonds. You can skip your practice right now because we're going to practice once we get to class. So let's go ahead and move down to covalent bonds. Now these are compounds that are made of molecules. Compounds that are made of molecules, have covalent bonds. So whenever you have a covalently bonded compound, it's going to have a molecular structure because it's made up of molecules. And I'm sorry, these are out of order. So atoms join by covalent bonds by sharing electrons. You've got to know that. Remember, ionic bonds transfer electrons. Covalent bonds share electrons. And you must know how electrons are transferred in the bonding experience. Covalent bonds occur usually between nonmetal atoms, so you usually have 2 nonmetals. So when you have to recognize and identify an ionic or covalent bond, you're going to look. If it's 2 nonmetals, you have a covalent bond. 2 or more nonmetals, you have a covalent bond. Now, most covalent bonds that are made of molecules have low melting points, and that should make sense from our last video. Remember, molecular structures have the lowest melting point of the 3 structures we talked about. So that should not be a surprise that they have low melting points. Most covalent compounds also do not conduct electricity. So even if you dissolve them in water, like an ionic compound, they still do not conduct electricity. So these are some ways that they are different from ionic bonds. Now, when you're making covalent bonds, you've got to know that they may share more than one pair of electrons. Sometimes they share two. And they always don't share them equally. Sometimes they share them unequally. Now, when you're making covalent bonds, there's two criteria that you need to meet. The individual atoms must have the proper number of valence electrons. I'm fixing to show you how to draw covalent bonds, and you're going to use the Lewis dot structure that we've practiced in class before. So you have to make sure, remember Lewis dot structure is how many valence electrons they have, so you've got to make sure you know how many valence electrons there are and that they have the correct amount. And then once you've bonded them with the other nonmetal, you've got to make sure that they have 8 electrons through the sharing process. So let's go ahead and look and do an example of how to make covalent bonds. All right, our examples for making covalent bonds. Up here you have 2 oxygen, that's 2 nonmetals. That's going to make O2. But how can we actually draw that? The very first step in drawing this is that you need to change. See how they have, oxygen has 2 electrons that are all by themselves. So you need to move any electrons that are by themselves to the middle. So we're going to go ahead and redraw, and we can put our paired electrons anywhere you would like on the other sides, but need to make sure, I have 2 unpaired, 2 by themselves, so I'm going to put those right in the middle, right there. Now my other oxygen, like I said, we place our original electrons that are already paired anywhere you would like for them to be, but my 2 I have to put right here that are unpaired. Now the way we draw this, do you see that there can be a bond drawn here? So that means they're sharing their electrons. So this oxygen now has 8 electrons, and this oxygen now has 8. And so the way you draw that, you can draw it that way with bonds, and I'm just going to circle this to show you that this oxygen uses all of those electrons. However, this oxygen uses those electrons, so you see the overlap. And so that's what we mean by sharing. And so the official way, to draw it would be where you have the double bond because it made 2 bonds, and that's how you would draw the covalent bond. Now, let's go ahead and look at fluorine down here. If I have 2 fluorines, it's going to make it F2. Now, I actually have already, I didn't mean to do this, but I had all of my paired electrons on the outside and my unpaired in the middle. So it's actually in the right spot for both fluorines. So we only have to make 1 bond here, right? And so since I didn't have to move my electrons, that made it a little bit easier. And I'm just going to show you with the circles, because to me that's a little bit easier to see how they share and how they have 8. And you've always got to make sure they have 8. If they don't have 8, then we've done something wrong. Okay, because once an atom bonds, it's going to have 8 electrons on the outermost energy level, or it's going to have a charge. Like if it doesn't meet the octet rule, it's going to end up having a charge. So my circle is going to be like this, and I can go ahead and draw my little bond right here, and so these circles show you that the fluorines both have 8 electrons that they're using, and so there was only 1 bond made though, so this is how you would draw the F2, because oxygen had made 2 bonds, but fluorine only made 1. Okay, now just so that you know, this right here is just how you draw the compounds. What we've done here is how you draw them. If you're asked for the formula is going to be O2. That's the formula, and then the name is oxide. Down here, the formula is going to be F2. So whenever you have the element symbol and how many atoms they have, those are formulas like we talked about earlier. And the names are when you actually write them out. And this would actually be fluoride. It's fluorine if it's all by itself. Once it comes together, it turns into fluoride. All right, so that concludes what we're doing today on today's video. This is what I'd like you to do. We're not going to do the practice, the 1 through 5, under make the following covalent bonds. We'll do that in class. But over to the right of that, there's some empty space, and I would like you to do your summary. And we're going to do the recipe summary. A recipe lists main ingredients, or the ingredients of a recipe. So what I like you to do is I want you to list the main ingredients of this video. That means the most important things. So go ahead and list the most important points or the most important things that you believe are listed or that we learned in this video. Have a great evening, and we'll see you in class.